Hello, my name is Nixon and welcome to the first module which is the Medium Access Protocol. So first we will discuss the two types of network, point-to-point and the multi-access or broadcast network. In point-to-point for station A to transmit to station F, station A should transmit and store the packet to station B and it will then be forwarded to C and then to D and until it reaches station F. Whereas multi-access or broadcast network utilizes a shared medium or channel which all nodes or station can use in transmitting. So the concern of the medium access protocols is more on the ways on how to manage the shared channel in multi-access broadcast network. So we will discuss the different protocols used in the multi-access. So first is the fixed assignment, the random access, demand assignment, adaptive strategies, and mixed mode. So this will be discussed one by one on the succeeding sections. So the first is the fixed assignment techniques. So we have the frequency division multi-access or the FDMA, which divides the channels into frequencies. So each stations are assigned to specific frequency which they can use over time. So the problem with this is the utilization since if there is no transmission for a specific station, the frequency is being unutilized. The next is the time domain multiple access or the TDMA where stations can transmit under specific type slot. So time slot is being assigned to a station for them to transmit. And the last is the code division multiple access or the CDMA where a station can transmit on a hopping pattern and it provides security since uh, the packet is being transmitted on different frequencies over time. So that's all. Thank you.
Hi, I'm Risa and I'm discussing about demand assignment techniques. The first type of medium access protocols, which is fixed assignment, was already discussed. Now, let's go to demand assignment technique, which assigns the channels based on the demands of the stations. This technique has two categories, those with a central controller that allocates channel to a requesting machine and those with distributed controller that does not have a lone central scheduler. Central control has two categories, the polling systems and the circuit-oriented system. In polling systems, all data exchanges must be made through the primary device even when the ultimate destination is the secondary device. The primary device controls the link while the secondary devices follow its instructions. Circuit-oriented system uses FDMA and TDMA subchannels that are assigned based on demand by a central controller. A ground station requesting to transmit selects an unused channel randomly. If the request is seen on the downlink, it means that the channel has been allocated for that station by the central controller, and no other station should use it. If a collision happened, the station should try again. The types of distributed control will be discussed next.
Now let's talk about distribution control in terms of the first in, first out reservation scheme. Reservations are made explicitly by the stations. The channel is divided into two kinds of slots, the data and reservation slots. The data slots are free from conflict because it is used on a reservation basis. The reservation slot is divided into small subslots which are used for transmission of reservation packets. And lastly, we talk about the mixed strategies. So one example given is one used in packet satellite channels. So several uplink channels may use slotted aloha while one of the several downlink channels use TDMA. So the usage of the shared channel is optimized if the proper ratio of uplink to downlink channels is appropriately chosen. Another example discussed is the reservation upon collision. So the channel time is slotted, which is divided into two parts: the SS0, the data subslot for information packets, and SS1, the subslot for the information regarding the users. Normally, the data subchannel is in the contention state, where users can access the slots using slotted Aloha mode. Once it becomes empty, the data subchannel goes back to the contention state.
Good day, this is Brian, reporting about CSMA/CD. Carrier sense multiple access with the collision detection is an enhancement on the random access techniques for multi-access protocols. This is particularly focused on addressing collision issues. Now, CSMA/CD started out as just CSMA only. What CSMA does is that it allows the stations to sense the carrier before they transmit. What happens is that this lessens collision, since if the channel has been sensed being utilized by another station, the other stations will not transmit yet. There are two main CSMA protocols whose distinction from one another is based on their persistence. The non-persistent protocol has a preset transmission or retransmission delay if the channel has been sensed busy upon a transmission attempt, while the P-persistent protocol keeps on sensing the channel's availability and then immediately transmits once it has been sensed idle. Now, CSMA/CD is an enhancement on the CSMA. This is primarily focused on channel utilization enhancement by lessening wasted time caused by the collisions. CSMA/CD makes the colliding stations immediately stop transmission upon collision instead of the previous setup, wherein the transmission will only stop after the first packet has been transmitted. In this setup, a fraction of a second is recovered from useless transmission, therefore improving channel utilization. Here's a quick summary.
Good day everyone. Today we will talk about network layer routing. When a device has multiple paths to reach a destination, it always selects one path by preparing it over others. This selection process is termed as routing. Routing is based on various types of metrics, examples of which are hop count and bandwidth. There are various types of routing: unicast, broadcast, multicast, and anycast. Let me give you an overview of what these types are all about. Unicast routing is the simplest form of routing where the destination is already known. The router just has to look up the routing table and forward the packet to the next hop. In broadcast routing, a broadcast message is sent to all network devices. Packets are sent to all nodes even if they do not want it. Multicast routing is a special case of broadcast routing, but the data is sent only to nodes which want to receive the packet. The router must know that there are nodes which wish to receive multicast packets, then only it should forward. Anycast packet forwarding is a mechanism where multiple hosts can have same logical address. When a packet destined to this logical address is received, it is sent to the host with its nearest routing topology. Let us move to the routing algorithm. Routing can be thought as an optimization process that requires the use of trees and process of traversing from one node to another in a typical tree structure. This is also known as graph traversal. The breadth first search and the depth first search are the two algorithms used for traversing and searching a node in a graph. They can also be used to find out whether a node is reachable from a given node or not. In depth first search, one starts at the root and explores as far as possible along each branch before backtracking. Stack is used in the implementation of depth first search. On the other hand, breadth first search aims to traverse the graph as close as possible to the root node. Queue is used in the implementation of the breadth first search. Let us move to a specific routing algorithm that can be categorized under any of the two graph traversal algorithms mentioned earlier: the plotting and the shortest path routing. Plotting is the simplest method of packet forwarding. When packet is received, the router sends it to all interfaces except the one on which it was received. In shortest path routing, decisions in networks are mostly taken on the basis of cost between source and destination. Hop count plays a major role here. Shortest path is a technique which uses various algorithms to decide a path with minimum number of hops. There are three common shortest path algorithms: the Dijkstra algorithm, Bellman-Ford algorithm, and Floyd-Warshall algorithm. Dijkstra algorithm is similar to the breadth first search, but with the edges not equal to 1. I guess that's all for today. Bye.
Hi, this is Pau Calma. I'll be discussing distance vector routing and internetworking devices. Distance vector routing is a bit more complicated than the shortest path algorithm. Each router must have a routing table which contains the computed distance to each destination and the best path to get there. This is achieved by estimating the delay to the destination by using the source's neighbor's data. Now to internet working devices, we have router, bridge, and repeater. So the router operates at the network layer. It's the most intelligent type of device. It can translate packets between different types of networks with different protocols. Routers are used in homes and offices today for Wi-Fi connections. Next, the bridge. It operates at the data link layer. It can store and forward data link frames from one LAN to another. Bridges are used to join two separate networks together. Lastly, the repeater. It operates at the physical layers, strengthens the signal, minimizes degradation, and lengthens reach. Repeaters are used when the signal is weak. That's all. Thank you.
Internet Protocol is implemented at the routers and its current version is 4 or IPv4. Its reason in the internet layer is for routing datagram or packets. Provides unreliable connectionless best effort service, also called datagram service. Unreliable, that is, it does not make an attempt to recover lost packets. It's connectionless because it's handled independently. It's not aware that packets between hosts may be sent in a logical sequence or out of sequence. It's best effort in the sense that it does not make guarantees on the service, nor throughput guarantee, nor delay guarantee. The basic data transfer in Internet Protocol is the datagram. Below is the datagram format, wherein it consists of a header part and a text part. The header has 22-byte fixed part and a variable length optional part. So in data transferring, every host and router on the internet has an IP address which encodes its network and host number. All addresses are 32 bits long. Internet Protocol address does not actually refer to a host. It refers to a network interface. So if a host is on two networks, it must have two IP addresses. IP addresses are divided into 5 categories. That is the host, host on this network, the broadcast on distant network, and the loopback. Subnet, on the other hand, is a technique of using portions of the host on address in an IP addresses to serve as an extension of the network. Manipulation of the subnet mask to get more networks as shown below. That is using the conjunction n to operate on given IP address as well as the subnet mask. So in adding a binary numbers where there is a presence of 0 makes the result as 0, while 1 and 1 is 1. So we have derived 199.20.10.32 out of 199.20.10.40.
Let's now proceed to Transmission Control Protocol, or the TCP. TCP is responsible for breaking up the message data from application layer into TCP segments and reassembling them at the receiver side. It also responsible for keeping the unordered segment in the right order, and it assures a reliable delivery by resending anything that gets lost while traveling the network. Below is the format of the TCP segment header, wherein the TCP is 20 to 60 bytes, followed by the data from the application probe. And it includes both source and destination port fields for identifying the application for which the connection is established. The sequence and acknowledgement numbers fields underlie the positive acknowledgement and retransmission technique, while the checksum field is used for integrity checks. TCP functions. TCP is multiplexing the data received from different processes so that they can be sent out using the underlying network protocol. TCP also provides a set of procedures that the device follow to negotiate and establish a TCP connection over which data can travel. TCP defines a mechanism by which applications are able to send data to it from higher layers. It is also responsible for the transfer of package data to the TCP process in the other device. It can provide reliability and transmission quality services, and it's have a feature on providing flow control and congestion avoidance.
A connection in TCP may be established through passive and active open calls. In active open, TCP issues a request for connection due to an upper layer control that provides the socket number. It is passive open when an upper layer control instructs TCP to wait for connection request from a remote machine. Usually, a passive open is waiting for an active open. To establish connection in TCP, the client and the server performs a three-way handshake to synchronize their sequence numbers and acknowledgement numbers. The sequence number is incremented by 1 for each byte, while the acknowledgement number is equal to the sequence number plus the good bytes read in the segment. TCP must also facilitate a graceful termination of connection. Using the FIN bit in the TCP header, the client will send a packet with FIN bit set to the server. The server will acknowledge and will no longer accept the data from the client. The server will also send a packet with the FIN bit set, and then the client will reply with an acknowledgement to finally close the connection.
TCP and UDP comparing transport protocols. Host-to-host layer protocols. Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). TCP is connection-oriented in the sense that prior to transmission endpoints, it needs to establish a connection first. TCP protocol data units are called segments. The sending and receiving TCP entities exchange data into the form of segments, which consist of a fixed 20-byte header, followed by a variable size data field. TCP is responsible for breaking down a stream of bytes into segments and reconnecting them at the other end, retransmitting whatever might be lost, and also organizing the segments in the correct order. The segment size is restricted by the maximum transfer unit, or MTU, of the underlying link layer technology. MTU is generally 1500 bytes, which is the maximum payload size of the Ethernet. The TCP segment format. User Datagram Protocol, or UDP. Unlike TCP, UDP is connectionless, where data packets can be sent without warning, preparation, or negotiation. There's no handshake or setup, just packets of data. UDP also lacks any kind of error control. Not only can packets be delivered in an incorrect order, but it can also get completely left out. UDP is meant for applications where you are more concerned with keeping the stream of information going than making sure you receive every single packet. UDP is ideal for real-time services such as voice over IP. With TCP, delays happen every time there's an error like packet loss. VoIP do not require completely reliable transport layer protocol. Why it matters for VoIP. The UDP and TCP protocols come into play with VoIP because they structure the way web traffic travels through the internet. TCP and UDP packets are sent from a source to your phone or computer, and if any of these packets are dropped, it will affect the quality of your call.
Hello, this is Angela, and today we're going to discuss on the application layer of the TCP/IP or layer 7 in the OSI model. So the first application is the domain name system or the DNS. So what it basically does, it provides us a mapping of the domain name with its IP address. So for instance, I'm a user and I want to access a website called turnonvpn.org. So instead of me memorizing the IP address for each time each time that I need to type it, what I can do is I could just query this DNS server and it would provide me that IP address. And from there, I could just make a request to a web server and I would get an HTTP response. So that's in real life me accessing a website. So that's basically how a DNS works. It gives me the IP address for me to access another site. And then just a quick review of the namespace. We have country specific. So for example, we have .au for Australia, .jp for Japan, .ph for the Philippines. And then we have other categories. We have .gov for government institutions. We have .edu for universities, .com for commercial establishments, and so on. Next one is Telnet. So Telnet is just a TCP/IP protocol which allows us to remotely access another computer. So for example, I'm here in the Philippines and I'm working on my laptop and I want to control or access another laptop based in Canada. So whatever I type in here or whatever commands that I want it to get executed on the computer located in Canada, I could just use Telnet and it gets executed or typed in this computer. That's basically how a Telnet works. Thanks for watching.
The World Wide Web, or WWW, or www, is not the application used, but is a domain that uses a set of applications and protocols to retrieve and store information displayed to the user as formatted text. The basic World Wide Web is composed of an internet browser, the Uniform Resource Locator, the Hypertext Transfer Protocol, and the Hypertext Markup Language. The internet browser is used by an end user to retrieve information from a computer server via the Hypertext Transfer Protocol, or HTTP. The Uniform Resource Locator, or URL, allows a user to access files and images in an HTTP server via the domain name or the direct IP address. The Hypertext Markup Language, or HTML, is a formatting language that allows the internet browser to display various texts and images in a document ready to be interpreted by the internet browser for the consumption of the user.
Hello, my name is JC and I'm here to discuss two common applications in the application layer. These applications involve certain file transfer across the internet. So FTP is the first application. FTP stands for File Transfer Protocol. It is responsible for allowing reliable file transfer across the network. So FTP can also handle large files. FTP does this by breaking down large files into chunks for faster data transmission. Some of the common FTP commands include open, close, by, binary, get, put, mget, mput, cd, lcd, dir, and hash. So for data transmission using the file transfer protocol, it utilizes port 20 to establish a connection in the FTP server. We can see this at the command channel, and then after connection has been established, Another connection to port 21 is established to for data transmission. Once data transmission has been finished, port 21 closes while port 22 remains open. So this is how FTP transfers files across the internet. Another application is the SMTP. So electronic mail also provides the capability to exchange messages in the internet. However, the amount of data for electronic mail is limited. So SMTP utilizes port 25 to relay messages to the mail server. So another protocol or like IMAP and POP3 is used to download the messages from the mail server to the client. So that's all. Thank you.